Good afternoon, everyone. My name is K. Pranavi and my roll number is 234G1E0488. I'm from ECEB section, and my topic in analog and digital communications is about DPCM. That is how the data reduction happens in the DPCM compared to the PCM. This presentation explores DPCM, that is Differential Pulse Code Modulation, focusing on its functionality, advantages, and comparison with conventional pulse code modulation. So let's see what is the definition of the DPCM. So DPCM is basically a signal encoder that uses the difference between successive samples instead of the absolute values of the samples for encoding audio or video data. So this method helps in increasing the efficiency of data compression by reducing the bit rate. So this is the block diagram of the DPCM. So here the sampled input is given to the summer, and this is the feedback signal which is given to the summer. This both signal is given to the quantizer, and we get the output DPCM output. Comparison with the standard pulse code modulation. We all know what is meant by pulse code modulation, right? So the pulse code modulation transmit every sample, whereas the DPCM transmits only the difference between the samples, leading to fewer bits needed per sample. So DPCM is more efficient, especially in the scenarios with similar SXSC samples, so it can be introduce additional complexity in the decoding process. So let us analyze the theory here. So you are given the analog signal which has the almost like a 10 amplitudes, where the amplitude is repeatedly given for the 2 times. So in the PCM, we give this data individually, that is, the data is given in an occurrence way. So in the DPCM, whereas we give the signal, we give the samples that are not occurred, that is not repeated at all. Data reduction mechanism. The data reduction in DPCM occurs by predicting the next sample based on the previous samples. The system encodes only the difference between the predicted value and the actual value, which typically results in a smaller data footprint compared to the standard PCM. This differential encoding allows for efficient storage and transmission of data without greatly sacrificing quality. So now I'm going to let you understand that there is an example that I'm considering a analog signal which has take the amplitude values, that is 1, 1.5, 1, 1, 2, 2.5. So this is my data of the analog signal amplitude values, and in the PCM we send these amplitudes as it is, whereas in the DPCM we'll consider where the occurrence happened and will only send the data that is not repeated. That is, now the data is 1, 1.5 to 2.5. That's it. So this is the how the data reduction happens in the DPCM when compared to the PCM. Impact on daily quantity. While DPCM reduces the rate significantly, it can also introduce quantization, noise, and artifacts in the constructed signals. The trade-off is an essential consideration. While data compression is beneficial for storage, and transmission care must be taken to preserve the quality of the original signal. Proper tuning of the prediction and quantization levels can help mitigate these issues. That is how. Let me explain what is meant by impact on the data quality. So when the DPCM occurs, there is some issues on this data quality. That is, it can also introduce the quantization noise, and also which can cause some signal error something. So this may impact the data. Lower bandwidth requirement. By reducing the amount of data transmitted, the DPCM lowers the overall bandwidth requirement, enabling more effective use of available network resources and allowing multiple streams to coexist without degradation, and also the improved compression ratios. DPCM achieves better compression ratios than PCM by encoding differences which are typically smaller in value than absolute samples, leading to lower bit data and storage in the digital media. So let us see what are some advantages of DPCM. So DPCM offers several advantages including reduced data rates, which leads to the lower storage cost and bandwidth requirements. We all know why we use DPCM, right? To mainly the function of the DPCM is to reduce the data. So which happens to leads to the lower storage cost. Like if the data is more, you need more storage, and if the data is less, then you need less storage, right? So it is particularly effective in scenarios where signals are highly correlated, as the differences between the samples can be very small. This results in less information needing to be transmitted, improving overall efficiency in the communication systems. Let us see some of the applications of DPCM. Use in audio and video transmission. So, why? So, to answer that question, in the audio and video, when you are sending a signal, it has some many data that are occurred like frequently. So, when you send it in a PCM, then it takes the more data and the bandwidth is more. So, now considering the DPCM, it can compress the data into smaller, so such as a voice over IP, that is VoIP, or digital division, where maintaining quality while minimizing data is crucial. Implementation in telecommunications. In telecommunication, DPCM is utilized to enhance signal quality and reduce the required bandwidth, allowing for more efficiency in transmission across networks, including digital communications. Role in image compression. DPCM is used in image compression algorithms such as JPEG. You all know what is meant by JPEG, right? Most of you actually use it as a JPEG. All your phone photos are in JPEG. So this DPCM used in the JPG where the pixel values are compressed but the quality is more. So let's, in the conclusion, we conclude that the DPCM provides an effective way to reduce data rates while utilizing the correlation in signals to encode information efficiently. Its application in audio and video compression demonstrates its importance in the modern communication. Understanding its mechanism, impacts, allows, and better utilization in various technologies. So overall, the DPCM, we study the, how the data is reduced when compared to the PCM. That is, in the PCM, we send the data that is whichever occurred frequently to, whereas in the DPCM, we only send the data that is occurred once. So this application will be very useful in the telecommunication system or in the digital image processing or signal processing. So this is the way this understands the mechanism and also improves to utilize the various technology and to improve the technology in the further days. Thank you.